TCP and UDP. We've already talked about TCP. Now let's talk about UDP communication. UDP is a simple protocol that provides the basic transport layer function. You'll remember that TCP has a lot of overhead. However, UDP has a much lower overhead. It's not looking for all the handshakes that are going on with the TCP communication. It's not connection oriented, and it does not offer the sophistication of retransmission, sequencing, or flow control. This does not mean that the applications that use UDP are always unreliable, nor does it mean that UDP is an inferior protocol. It's just a different protocol. Although the total amount of UDP traffic found on a typical network is often relatively low, there are key application layer protocols that use UDP, and these include our DNS, which is our domain name system, Simple Network Management Protocol, the SNMP. We have Dynamic Host Configuration Protocol, which is DHCP. We have Routing Information Protocol, which is called RIP. We have Trivial File Transfer Protocol, which is TFTP, and then we have our IP phone or voice over IP, which you'll see as VoIP, and then you have your online gaming that uses UDP. Some applications, such as your online games or voice over IP, can tolerate some of the data loss. If you've ever noticed when you're doing online gaming, you might have a hiccup in it. It's because all the stuff hasn't transmitted at once. Sometimes you may not hear the complete conversation, but you can always say, do that again, say that again, and some people can repeat it. If these applications use TCP, you would experience a large delay in the gaming or the phone call itself because it's waiting for everything to get put into place. So the low overhead of UDP makes it very desirable for these applications. Because it's connectionless, the sessions are not established before communications take place as they are with TCP. Like I said, it's going to send everything, and then if you're missing information or things aren't looking quite right, you can always say, hey, send it again. UDP simply reassembles the data in the order that it was received and forwards it to the application. And if the data sequence is important to the application must identify the proper sequence and determine how the data should be processed. It's not up to UDP to take care of that. It's up to the application itself to take care of this information. Like our TCP-based application, UDP-based server applications are assigned well-known or registered port numbers. And then when the application or processes are running on a server, they accept data matched with the assigned port number. And when UDP receives a datagram instead of one of these destined for one of these ports, it forwards the application data to the appropriate application based on that port number. Okay, so port numbers are important. With TCP, the client-server communication is initiated by the client application that requests data from a server process. The UDP client process randomly selects a port number from the range of dynamic port numbers and uses this as the source port for the conversation. The destination port is usually the well-known or registered port number assigned to the server process. Randomized source port numbers also help with security. Okay, so keep that in mind. There's always a reason for everything we do. Because there is no session to be created with UDP, as soon as the data is ready to be sent and the ports identified, UDP can form the datagrams and pass them to the network layer to be addressed and sent to the network. And after the client has selected the source and destination ports, the same pair of ports is used in the header of all datagrams used in the transaction. And for the data returning to the client from the server, the source and destination port numbers in the datagram header are reversed because the source was the destination and the destination was the source, basically. So you can go through here and see the same information as we did with TCP to see how this information works. You will have a lab using Wireshark to examine the UDP in the DNS capture. This works best in the live lab, not so much in the net labs as we don't have internet access, and it also tends to work better in the live lab as compared to the packet tracers.